Hello, everybody. This is Mr. Fluharty. So this is part two of our unit on chemical reactions. We're going to continue from where we left off in part one. And so basically what we're doing is we're running through some problems that will demonstrate the concepts that you need to learn in order to understand chemical reactions. So first of all, I am going to get rid of my portrait so that we have more room on the screen. So let's go to where we left off. Okay, so here in the following situations, the open circles represent oxygen, the closed circles represent nitrogen. Write the chemical reaction that goes with each picture. So here's an example. If you have a nitrogen molecule, and notice that we don't say dinitrogen, we say just nitrogen because we know that it's two nitrogens. And then we have an oxygen molecule indicated by the two open circles that are touching each other. The fact that they're touching each other, that means that they're chemically bonded. And then they're going to make two nitrous oxide, nitrogen oxide molecules. Notice the arrow, that means that that's during the reaction, and what's going on is the molecules are ripping apart into single atoms and then they're coming back together as the new molecules, the product. The subscript on the right, that indicates how many of that particular type of atom is inside the molecule. The coefficient on the left, the big 2, that's how many there are. Okay, so let's try this one. Notice that all of these start with nitrogen and oxygen. In this case, there's 1, 2 nitrogen molecules, so I put a 2 there. There's 1 oxygen, but I don't have to put a 1 there. We don't write down the 1. And then we have 2 of these, and notice that there's 2 nitrogen and 1 oxygen. And 1, 2, there's 2 of them, so I'll put a 2 there. Okay, let's go down to the left. Again, we start with nitrogen and oxygen. 1, 2, there's 2 of these. And there's 2 of these. Then we end up with this molecule here. 2 oxygens, 2 nitrogens in the molecule, and I have to put a 2 here. Okay. Why do we put the nitrogen first? Well, it's to the left. If you look at the periodic table, it's to the left of the oxygen. You always try to put the element that has the lower electronegativity to the left. And in this case, the nitrogen is to the left. Again, nitrogen. There we go. And oxygen. Let me see, how many nitrogen? Looks like there's 2 of them. How many oxygen? There's 4 of them. Okay. Here we have in the molecule and oxygen, there's 4 of them. Oops, I don't know why it did that. But there's 2 of them. Okay, notice this one, nitrous oxide. This is laughing gas. And that's if you go to the dentist and he's going to do a very painful procedure on your teeth, you might ask for the laughing gas. Okay, draw pictures to represent the following chemical reactions. Okay, carbon, I will make that a closed circle. Hydrogen, I will make that an open circle. And then oxygen, I will make that a striped circle. So we have a carbon and we have two hydrogens. 1, 2. Then over here we have a carbon in the center and we have hydrogens hanging on the outside. Over here we have two hydrogens and we have one oxygen molecule. And then over here, and this is just the water reaction. So we have to draw two water molecules. Okay. Do an atom inventory. Okay, here's something that's a little bit more involved. What is an atom inventory? So what you're going to do is you're going to write down each element that's in the reaction. So we have lithium and we have oxygen. And then you're going to make a table that has reactants on one side, and I use an R to indicate reactants, and products in the second column. So count how many lithium there are on the reactant side. Well, there's 4 of them, indicated by this coefficient. How many oxygen are there? There's 2 of them, 2 oxygen atoms. On the right-hand side, there are 2 times 2, that's 4 lithium. And since there's 2 of these compounds, there's 2 of them, you have 2 oxygens. Okay, let's do this again. We have aluminum, we have bromine, we have the reactants, and we have the products. Okay, aluminum, there are 2 aluminums on the left side of the arrow, and there's 3 times 2, 6 bromines. On the other side, there's 2 of these molecules, right? Aluminum, and then 1, 2, 3 bromines. But there's 2 of these, so there's 2 aluminum, 2 times 3 is 6 bromine. Okay, let's try one more. We have nitrogen in there, and we have hydrogen. Reactant side and product side. So every time you do one of these problems where you're trying to figure out how many atoms are in the particular reaction, you have to do this. You have to make this table. Nitrogen, there's 2 of these, and each one has 1 nitrogen, so 2 times 1 is 2. There's 3 hydrogens inside the molecule. There's 2 molecules. 2 times 3 is 6. On the product side, there's a nitrogen molecule, which is 2 nitrogen, and there's 3 hydrogen molecules. 3 times 2 is 6. And that is the end of part 2. We're going to continue with the next video, and we're going to do a lot of practice on what we're doing right now, which is balancing chemical reactions. See you next time.